Right, can we all see that?
Yep, if you just start the presentation.
There we go.
Perfect.
Okay. As Stephen has said, I'm the Technical Director for Transmag, Technical Director for a company called Critical Power Applications and Solutions, and very proud to be the Chief Consultant Electrical Engineer for ESIPAC for UK, France and Commonwealth. So, what is an arc flash? Well, an arc flash, as it states there, is a short circuit through air that flashes over an exposed live conductor, either to ground or more than often than not from 2 conductors or even 3 conductors. So let's take a closer look. We've got a very short video here, which some of the little videos on here you will have seen parts of before, but let's kick off with this one.
An arc flash is the first stage of an arc blast. Most have seen the video evidence widely available. Arc flash is an event that can occur in any switch room, substation or panel, LV or HV. The flash develops rapidly, in less than 1/3 of a second, to an explosion, a blast with massive pressure that causes significant collateral damage, creating a temperature of twice that of the surface of the sun. Molten metal fragments, toxic fumes, an ear-rupturing explosion with eye-damaging intensive light. Life-changing and life-threatening injuries. Significant downtime and rebuild costs, with criminal prosecutions for company owners, the health and safety duty holder and engineers. All this along with damaging media coverage.
As it states there, we don't want to make it the end. So how rapid is an actual arc flash situation? Well, try and imagine 1/3 of a second. Now, if you were to blink your eye at this moment in time, if you just blink, that is literally 2/3 of a second. So if you half that, that's how quick this takes place. So from that first frame to that last frame is less than 1/3 of a second. I've tried to do it in real time, but I can't get it down to as quick as that. But it's something like this. We'll try that again. Something like that. So really, you haven't got time to sort of pull away or try and get into a safe area, because that's how rapid the occurrence is. So today is all about how do we prevent going from that situation to this situation. So let's talk about the severity and the sustainability of an arc flash. Those are the two terminologies. First of all, the sustainability is the gap between arcing contacts. So when the first design is made, whatever that gap is determines how easy it is to get an arc flash to cross across those contacts. And the voltage between the arcing contacts gives you the energy level that you'll get in that sustainability. However, the severity is determined by the working distance, and I'm sure you've all heard of the working energy distance, and the duration. If we look at that chart in a little bit more detail, that is a chart of half a second. So we're going from absolute no problem whatsoever to a full-scale explosion in the space of, as I say, around about 300 milliseconds or 1/3 of a second. So some of the typical causes of an arc flash on an arc fault in a switchboard or a substation, these are very typical of some of the things that you may find have caused them. The one that I've come across more often than not, well, there's two actually, is the tools dropped or left behind. So I'm a big advocate of, if you're going to do a job on an electrical switchboard, do a tool counts in and a tool count out. It's quite simple, it's quite easy, but it's a reassuring way of knowing that you have actually taken all the tools out that you actually brought in with you. And the other one is mechanical failure and loose connections, usually because Many switchgear substations do not have the maintenance routine that's recommended by the OEMs of the particular breakers, etc. It's seen as an economic without actually gaining anything. Well, the gains, it's the losses that they ought to be considering rather than the gains. I visit lots of switchgear rooms and substations in the course of a year, and I've always got my eyes peeled. I'm always looking at what's the building like? You know, what sort of condition is it in? Is it locked as it should legally be? Is the signage there for what the calorie levels are? Often I see worn or even absent insulation mat, and it could be argued that a worn or a turned up insulation mat is even more of a hazard than not having a mat there at all. You often see rusted switchgear and metalwork, rodent activity, open chambers. How many times you go into a switch room and see somebody's left one of the covers open? SLDs out of date. It's more rare to find a single line diagram drawing that's in date than it is to find one that's out of date. And of course, no switching and isolation register. It's a rarity to even see a register, and just the general state of the switchgear itself. So what are the consequences of the arc flash occurrence? Well, from a personal point of view, you've got the pressure. You know, that is one hell of a blast, that that you'll be feeling. I have seen the after effects of an arc flash incident where it's actually blown the back wall out altogether. So on situations like that, even arc flash PPE is not going to necessarily save your life. Heat, the exposure to heat, you're likely to come across temperatures up to around 10,000 degrees C, or twice the surface of the sun. The sound of it, eardrum blasting sounds that shatters the hearing. Toxic fumes and molten micro fragments all happen in that 1/3 of a second. And as soon as you get the idea that that blast is taking place, the first thing that you're going to do is you're going to take a deep input of breath. And more often than not, the damage caused by the toxic fumes and the molten microfragments are the worst injury effects that you actually get from an arc blast. And of course, the extreme bright arc flashlight. We've all seen people doing arc welding. You know the intensity of that light, and that's what you're going to come across. So from an organization point of view, what is the collateral damage that often occurs? When you've got the damage itself, often the switchboard itself is completely ruined. The downtime taken before you can actually either get the health and safety executive to release it for repair, if they're doing an investigation on it, which happens more often than not. Then the cost of the actual rebuild, as well as the time of the rebuild, the lost revenue in production, and one of the most significant ones is the damaged reputation, particularly nowadays with social media. And the press avidly looking for reports on prosecutions for arc flash incidents. And of course, it alienates the workforce. I get to talk a lot to engineers, and you can judge from how their employer actually treats their safety as to how bought in they are to actually work in there. I've seen some really good systems. I've seen some really poor system. So it's worth looking at what you have in place, and don't be afraid to speak up to your employers. Sometimes they're just totally ignorant of what they should be doing, but we'll go on to that a little bit later. And then finally, health and safety executive prosecutions. Not many people realise that the Health and Safety Executive is a standalone organisation. It's no longer a government-funded organisation. It makes its money from its prosecutions and its fines. I've had a lot of communication with the Health and Safety Executive. We're not going to get guidance on arc flash. They've made it quite clear. And why? Well, we can all speculate as to why. Sadly, I think it's got a lot to do with the amount of money they collect in fines. So what methods of prevention are available to us? We're going to be considering the safety of our engineers above anything else, aren't we? And how do we put in practice in place that everyone can feel confident that it will be safe? How can we ensure the engineer or the subcontractor is competent? And it is the responsibility of the employer for both employees and subcontractors. And how can we ensure the SAP is carrying out correct works on the correct system? Well, there's something that's been put in place that is recommended by the Health and Safety Executive, it's recommended by the IET, and it's also recommended by the NFPA 70E, which is sometimes the only standard that we've got to work to. And that standard is called the hierarchy of control. And I can't endorse this well enough. If you follow the hierarchy of control, the chances are you're never going to have a situation that puts your guys or yourself in danger. And what is the hierarchy of control? Well, it's 5 steps. First and foremost, if you can carry out the first one, which is dead work only, then you're pretty safe, aren't you? But bearing in mind, somebody's got to isolate, somebody's got to prove dead, somebody's got to confirm dead, somebody's got to put it down to earth, somebody's got to re-energize it. So dead work only can be a little bit of a fallacy. There's removal, which is my personal favourite, using technology to prevent the level of calories being to such an extent that it can actually either critically injure you or kill you. Then, of course, there's engineering, remote switching, Form 4B, parcel discharging, which you'll hear a lot more from Jason in the next presentation, thermal imaging monitoring, and things of that nature. Processes. I think this is probably the most important of all the steps. If you've got your processes right, if your documentation is correct, if you follow a standard that you know it covers all of the aspects of these, then you're in pretty safe territory. And last but certainly not least is PPE. Whose responsibility is it? Well, it is the responsibility of the employer to make sure that all of their employees, before they take place in any electrical works, that they have the appropriate arc flash PPE. So let's just run through them. I've already mentioned elimination. Yeah, we've got the isolation, the earthing, the proving dead and confirming dead. Number 2, how do we prevent that occurrence? Removal of the hazard's effectiveness. When we look at arc protection, relays and quenchers, specifically designed to quickly remove a fault. It adds a substantial layer to safety, and in some countries it is actually legislated. If you look at the USA, parts of Scandinavia, and it's creeping more and more into Europe now, the design of technical capability of preventing a dramatic arc flash explosion should be part of the feature that you do when you design a switchboard. It gives you automatic compliance for the health and safety with regards to the category of arc flash PPE. It will dictate to you exactly what the calories per centimetre squared are, both at the working energy level and also at the boundary levels. Confirmed category without an energy audit. Look, we carry out energy audits ourselves, arc flash assessments, arc flash studies, and they're well worth having, but they are an MOT. The minute that you change anything within that, within the infrastructure, it's outdated really, and it needs to be done every 5 years, and not every organisation can afford the thousands of pounds that they actually cost. So this is a good way of making it a standard there that does control the calories per centimetre square. So it protects equipment, obviously, and costly replacement. So that's the argument that you do to the higher echelons. But from an engineer's point of view, it prevents life-changing injuries. Safe and reliable distribution and working areas, and minimising all those economical consequences that we just spoke about recently. So how do we determine the arc flash severity? Here's another little short video that will hopefully explain just that.
So, what are our options? The contact gap can only be affected at the time of design, so we can do nothing further with regards to that existing gap. The distances will be whatever the distance required to carry out the task, so we cannot affect that. However, the duration, which is the most critical element, is what we can and will drastically reduce with an ArcTech arc flash relay. The quickest responding relay on the planet, taking just 0.02 of a second to send that trip signal at the onset of an arc. So, how does this incredible device operate? The ArcTech relay can be operated by any selected combination of light, pressure, or inrush over current. We connect to that ArcTech relay, either sensors or fiber optics, or even both, at the most appropriate points, along bare bus bars, close to any terminations and, of course, any circuit breaker vicinity. These actuates at the outset or inception of an arc flash incident. Within 2 milliseconds the trip signal is triggered to open the incoming breaker that feeds that circuit and therefore isolates the fault. ArcTech relays, with over 50,000 arc flash relays in service globally and without a reported failure to affect an arc flash incident as described earlier. We offer free design to any existing or new electrical system. An incorporated ArcTech arc flash relay will reduce energy permanently to below 8 calories per square centimeter, which equates to safely recommending Category 2 arc flash PPE for working and attending engineers. The relays are self-supervisory, so even a loose connection, or a device not functioning correctly will be immediately flagged up and illuminated, without any impact on the circuits being protected. Additional I&O allows alarm or fire suppression triggers, with even the capability to report the failure to a designated engineer via email or text.
So there are obviously other arc flash relays that are available, and every one of them does the job that you want it to do. That is just a standard demonstration that I give on some of my presentations as I represent ArcTech. But as I say, any arc flash relay will give you a performance that will reduce the calorie levels, but you'd have to look into them as to see what level they could bring it down to. So we're trying to eliminate that situation. A relay will actually give you that, a guarantee of a lifetime of 8 calories per centimeter squared as a working energy level, as long as that relay is operational. That brings it down to that, which is a lot more comfortable for an engineer to work in than the previous slides. But what if you could get it down to that? Well, you will be very pleased to hear that we can actually get it down to that with one of those, an arc quencher. So what is an arc quencher?
I don't know if there's supposed to be sound on this video, David, but it's not coming through. I don't know
No,
if you just...
there is no sound on this one.
Right, okay. Might be worth just talking through what's happening.
Yeah. Yeah, this is a typical arc quencher. The sound's been taken off it really from a marketing point of view. It's not about marketing a particular type of quencher. That one is one that we sort of market, which is the Arctic arc quencher, simply because it's resettable and reduces the calorie level down to around about 1.2 calories per centimetre square. But there are other suppression systems on there. It can do one that is a suppressant. And Siemens also do an arc flash quencher, which is in partnership with Arctech. So there are other types about as well, and they all do a very similar type of job. So one of our biggest threats at the moment, and I would say probably at least 1 in 3 switch rooms and substations that I see, has got oil insulated switchgear from yesteryear, still in abundance, and giving calories per centimetre squared is way off the scale. Even category 4 arc flash PPE will not cover many of the installations that was done in yesteryear. That doesn't mean to say that you shouldn't wear it just because it probably is a calorie level above that. And in fact, it's probably an even better reason to wear it, because some protection is always better than no protection. But I did have a situation where I had an application on a solar farm where a substation had actually blown up, and health and safety executive were involved. So they carried out the investigation over a 3-month period, which meant that that substation could not be rebuilt. It then took a further 3 months for the rebuild to take place, and then it was started back up again. The company concerned heard about what our company was doing with Arc Flash. They got in touch with us and said, "Oh, how much would it cost to have done, and how long would it take?" So the cost to have it done wasn't the sort of thing that put them off. It was the fact that, well, if you fit it to your panels and that, after the survey, it was estimated that it'd be a day and a half, maybe 2 days to fit. And it was that said, oh, well, we can't afford to have that sort of downtime. So therefore, we developed a panel. And that is the panel, the very panel that was actually fitted there. It's the Arc Guardian. We can do all of the work that needs to be done whilst the electricity is still flowing nicely. We only need between 15 minutes to half an hour of downtime to actually lay down either the sensors or the fiber optics that we use. And this is just a really easy way of eliminating too long a downtime, and is proving very popular indeed. So there's always a way around of being able to treat those high levels of calorie per centimetre squared. So if we go to the IR Archive Control 3, Engineering Solutions, I came across this arc switch, which is a genius device for being able to remotely switch breakers. There's also a company in Manchester called PSI Group who manufacture retrofit breakers, 11 kV retrofit breakers, with their own individual remote switching capability. Absolutely excellent, and a good layer to be able to put on the hierarchy of control. I've already mentioned partial discharge, and I'm not going to go into it too much because I'm not going to steal Jason's thunder. But what a brilliant little thing this handheld monitor is. Should be applied before you go into any switch room or any substation. But again, Jason will go into that into a little bit more detail later on. So the hierarchy control process is the one I believe is the most important of all the steps. We can do an arc flash study and assessment, as I say, if that's the way that you want to go down. That will certainly dictate what your calorie levels are throughout your infrastructure. But the other processes that you need, it's a legal requirement to have an up-to-date SLD evident and on display. The signage, does it actually state on the signage of your switchboard what the calories per centimetre squared is? What category Arc Flash PPE is recommended? It should do. Arc Flash PPE should be free issued by employers, and it shouldn't be just heat retardant PPE. It should be Arc Flash PPE. If you're going to do planned outages, you need to do planned recoveries as well. What if something goes wrong? You need an escape plan. Documentation is critical. Switching method statements, you know, to simulate the switching that you're going to be doing. To do a walkthrough on a switching method statement is such a great practical way of knowing that what you're going to be switching is actually going to do the isolations that you need it to do. RAMs, risk assessment now is a legal requirement, and those risk assessments should state on there what the calorie levels are and what Arc Flash PPE, if any, is recommended to be used. And of course, permit to work with any restrictions. I heartily recommend dynamic risk assessments, dynamics, that before you actually start your work each day, just run through a risk assessment. It's simple enough to do, takes a couple of minutes, and just in case there's any increased hazard that's come onto the another activity that's happened or occurred, and it just makes you aware of what's going on around you. The pre-outage walkthrough simulation I've already mentioned. With every works that involves electrical isolation, there should be a safety person elected and present during those work. And obviously the prove dead and confirm dead, but the lock tag and register log, I come across a lot of companies that use lock and tag or lotto, but they don't have a process in place. They don't have a register. They don't have nominated signage and things like that. And I was at a company yesterday, I'm sure they won't mind me dropping the name out, NetWise, who have got this fantastic system. Everything is up there on the wall. You can see everything that's been taken out just at a glance of what they've got there. So it's one thing to have a lock and a key. It's another thing to have the process that goes with this. And it is something that you will be interrogated with if something goes wrong on a lotto. The health and safety executive will want to see all the documentation that goes with it. And then finally, as we say, the Arc Flash PPE. We know whose responsibility is to provide it, but whose responsibility is to wear it? It is, of course, your responsibility. So PPE or prevention, sometimes we cannot prevent, often we need both, and always it is the SAP's only section of the hierarchy control that is in their total control. So just to mention, Transmag are very a part of the CPAS Alliance. All the companies that are on it today work alongside in collaboration with CPAS. And it gives a good partnership for engaging approved customer focus engineers. There's also a website that is sponsored called www.arcflashinfo.co.uk. It's a great refresher for some of the things that we've spoken about today. And we have our first annual Arc Flash conference coming up, all about Arc Flash UK conference. The date's still to be confirmed, but it's at the Belfry. We've got some great international and national speakers lined up. Mr. Jim Phillips is doing the introduction, who is the working committee member of NFPA 70E. He's also a director of IEEE, along with a lot of other decorations that he's been given. It's certainly a worldwide influence on Arc Flash. ETAP, the globally known software for Arc Flash assessments, they're going to be there as well. And we've got some really great UK personalities and characters that will be attending and sitting on the panels as well. So that's one to look out for. And this is just to remind you that we've done it 1,000 times before. I know what I'm doing, but it is a lottery, and the next time it could be you.